Hey everyone! In this video we are going to be solving unknown angles in right angle triangles, and we will be using our three trig ratios sine, cos, and tan. Let's go ahead and get a practice problem up here. So we're going to label a theta, that is an unknown angle, and we'll put our little right angle in here just so that we know it's a 90-degree angle, and we'll write those in yellow because that's a lot brighter than the red on the black. We still have to be able to identify our opposite, our hypotenuse, and our adjacent. That doesn't go away. In this case, across from our right angle, we have our hypotenuse, and between theta and the right angle, we have our adjacent. We can see that the opposite side isn't used. The trig ratio that uses the adjacent and the hypotenuse is cos. Let's go ahead and set this up. Cos of theta will equal our adjacent side, 10, over our hypotenuse, 30. You can't just divide both sides by cos, though, and get theta. There's an operation in your calculators. It's called arc cos, but we could say inverse cos. Some of my students say cos to the -1, but it's the inverse cos. And what it does is it gets rid of cos on one side so that we can get theta all by itself. At which point you can go to your calculator. This inverse cos function, it's usually second function on most graphing or scientific calculators, but if you put in inverse cos and in those brackets 10 over 30, it will spit out your answer, which I rounded to 2 degrees. If you don't get that 70.53 degrees, check to make sure that you're in degrees and not radians. Sometimes calculators come in radians by default. Let's go ahead and do another example. Now we have a brand new triangle. We've labeled 2 new sides. We don't have the hypotenuse this time, so we can't be using anything that has a hypotenuse in it. That kind of helps us out. We do have the opposite side, and we have the adjacent side. So we know we're going to be using our tan. We can set this up as tan of theta is equal to our opposite side. Tan of theta equals opposite, 12 over our adjacent side, 20. We can't just divide both sides by tan. We have to use that inverse tan function in our calculators. And if we do the inverse of tan of 12 over 20, it will give us that unknown angle, which is 30.96 degrees. As long as you're doing the inverse of tan and you have the ratio set up correctly, you'll get your angle. One more example, we're going to move theta someplace new. And now our theta is up at the top. What this does is it changes which sides are our opposite and our adjacent. So we want to be careful when we're labeling our triangle. We're still dealing with our hypotenuse because it's across from the right angle. But now our opposite is down here. Our theta's up here, the side opposite is down here. We're looking for our trig ratio that uses the opposite and the hypotenuse. That's our sine. We write our equation out. Sine of theta equals the opposite side, which is 5, divided by the hypotenuse side, which is 12. In order to get rid of a sine, you can't divide by sine. If you remember that every time, you said you can't divide both sides by sine, we have to use the sine inverse, that inverse sine function. In order to get rid of a sine, put that directly into your calculator. The arc sine of 5 over 12, theta will equal 24.62 degrees. Hopefully what you found is that solving for the angles is actually a little bit easier algebra-wise than solving for the sides. I hope that this was helpful, and good luck solving your questions.